Next problem. Two population have the same mean, but the standard deviation one is twice that of other. Show that the sample of 500 each drawn under simple random conditions. The difference of the mean will in all probability not exceed 0.3 sigma, where sigma is the smallest standard deviation, and assuming that the distribution of the difference of the mean to be normal, find the probability that exceeds half that amount. So let mu1 mu2 be the means of population and sigma 1 sigma 2 be the standard deviation of the population. Given two population have same mean, so mu1 equal to mu2, so take it mu, right? And standard deviation is 1 is twice of the other, so sigma 1 which is equal to 2 sigma 2, right? So 1 is sigma 1, that is 2 sigma 2. Also given that sigma is the smaller standard deviation, so sigma 1 equal to 2 sigma 2, so in this case sigma 2 should be smaller because sigma 1 twice the sigma 2, so that is why we are taking sigma 2 is equal to sigma. So sigma 1 is equal to 2 sigma 2, that is equal to 2 sigma, right? Given sample size both are equal, n1 n2 is equal to 500. So x1 bar x2 bar be the sample means, right? To prove difference of the sample means will in all probability not exceed 0.3 sigma. To prove in all probability, so modulus value difference x1 bar minus x2 bar not exceeding 0.3 sigma, so less than or equal to 0.3 sigma. So test statistics, x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2. So x1 bar minus x2 bar divided by root of sigma 1 is 2 sigma the whole square, right? 500, n1 is plus sigma 2 is sigma, so sigma square by 500. So x1 bar minus x2 bar 4 sigma square by 500 plus sigma square by 500. Taking sigma outside, so x1 bar minus x2 bar by sigma into root of 4 plus 1 by 500, that is 5 divided by 500, so 5 and 500 get cancelled, so 1 by 100 root, that is equal to 10. So the x1 bar minus x2 bar into sigma by 10, right? That is Ez, that is equation number 1. We know that in all probability that a standard normal variate between plus or minus 3. Maximum value of Z is equal to 3, right? So Z value, that is x1 bar minus x2 bar by sigma by 10, which is lies between plus or minus 3, that is mod sigma is less than or equal to 3, so less than or equal to 3. So x1 bar minus x2 bar less than 3 into taking that denominator sigma by 10 to the other side of the inequality, so sigma by 10, 3 into sigma by 10, so mod x1 bar minus x2 bar is less than or equal to 0.3 sigma, which is to be proved. Next problem, a random sample of 500, the mean found to be 20 and another independent sample of 400, mean is 15. So first sample size n1 500, sample mean x1 bar 20, second sample size n2 is equal to 400, sample mean x2 bar is equal to 15. Could the sample have been drawn from the same population with standard deviation 4? It is from the same population or not, they are asking, right? Population standard deviation sigma 1 sigma 2 which is equal to same population, that is why it is equal to sigma, that is why we are taking sigma, both are equal to 4. So hypothesis H0, there is no significant difference, right? There the same population, right? mu1 equal to mu2, right? Alternate hypothesis opposite to that, mu1 not equal to mu2, two-tailed test, so it is not from the same population, right? Two-tailed, let the level of significance they have not given, so that is why we are taking 5%. So in all problem if they are not given, then you take 5% level, significance level. Test statistics Z is equal to x1 bar minus x2 bar by root of sigma square into 1 by n1 plus 1 by n2. Substituting the values, 20 minus 15 divided by 4 into root of 1 by 500 plus 1 by 400. So you will get 18.6359. Calculated value 18.6359. Tabulated value at 5% level 1.96. Clearly calculated is greater than tabulated. So H0 is rejected. That means H1 is accepted. That means the samples are not from the same population with standard deviation 4. Next problem, in a certain factory there are two independent parts, right? The average weight is sample of 250 items produced from one process is found. Two independent process means two factories, right? Two part, right? In a factory there are two production units. So first process, second process. So the average weight in a sample of 250 items produced from one process is found to be 120 ounce with standard deviation 12 ounce, while the corresponding figure in the same in a sample of 400 items from the other process 124, mean is 124 and standard deviation is 14. Obtain the standard error of difference between the sample means if the difference is significance. Also find 99% confidence limit for the difference in the average weights of items produced by the two processes respectively. Given sample size n1 is 250 and n2 is equal to 400. Sample mean x1 bar 120, x2 bar 124. Sample standard deviation also they have given, right? 12 and 14. Standard error formula, first standard error is equal to root of s1 square by n1 plus s2 square by n2. So s1 is 12 and s2 is 14. So root of 12 square by 250 plus 14 square by 400. So you will get 1.0325. Hypothesis H0 is mu1 equal to mu2. There is no significant difference. They are asking this second question, is this difference in is this difference significant? They are asking, right? No significant difference. H1 two tail mu1 not equal to mu2. There is a significant difference, right? So the level they have not given, right? Only they are asking in the third question 99% confidence limit. So taking 5% level of significance. So test statistics z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. So substituting the values 120 minus 124 by 1.30325. So you will get minus 3.874. So modulus value, that is calculated value of z 3.874. Tabulated value 5% level 1.96. So calculated value is greater than the tabulated value, therefore H0 rejected, therefore there is a significant difference. Next we are going to find 99% confidence limit. So formula is for the difference, so that is why we are taking the difference. So modulus x1 bar minus x2 bar plus or minus z alpha root of s1 square by n1 plus s2 square by n2. Substituting these values 120 minus 124 plus or minus 2.58 into 1.0325. So we will get two values. One is 4 minus 2.6637, that is 1.3361, lower limit. Second value 4 plus 2.6637, that is the upper limit, 6.6639. Thanks.